Hello, geometry students. Mr. Zacek back and better than ever in Unit 8, Lesson 4. We're going to be looking at angles of elevation and angles of depression and using some trig to help us solve these. This is going to be a pretty quick lesson. It's just a little bit of application from Lesson 3 on trig. So if we've got a picture over here and it says, suppose a person on the ground sees a hang glider at 38 degrees above the horizontal line. This is the angle of elevation. So see this person in the picture here and they're looking up, and so that's what we call the angle of elevation. At the same time, a person in the hang glider sees the person on the ground at 38 degree angle below the horizontal line. So if they were looking straight out, that would be the horizontal line. This is the angle of depression. So if you notice that the angle of elevation is congruent to the angle of depression because they're alternate interior angles, so really like these lines are parallel to each other, and we can use the angles of elevation and angles of depression as the acute angles of a right triangle formed by the horizontal distance and the vertical height. So we can create a right triangle here, and when we create that right triangle, that's going to allow us to use trigonometry. So what is the description of the angle as it relates to the situation? So as we look over here, angle 1, see it's that hang glider here looking down, is the angle of depression. And angle 4, person on the ground looking up, we would consider that the angle of elevation. All right, so just being able to identify that that we have here. So again, 2, that would be an angle of elevation. That's the person in the balloon looking up. But angle 3 would be the angle looking down. All right. So love these questions. I like to ask them. It's a way to just kind of apply the trig that we, the right triangle trigonometry relationships. So you spot a rock climber on a cliff at a 32 degree angle of elevation. Your eye level is 6 feet above the ground and you are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? So we've got this right triangle. This is representing the height here. Now we need to remember that we're going to have to add 6 onto the bottom of that, or to the end of it at the end of this question here, to get the height, because the eye level is 6 feet. So this is the hypotenuse, so we're going to circle our angle here. That means this would be the adjacent, and this length over here would be the opposite that we're trying to find. So this is a right triangle trig question. We have a right triangle, we have an acute angle, we have one side, and so Tom's old aunt, okay, sat on her cat and hollered. All right, what do we know? Well, we know the adjacent, we're looking for the opposite. This is a tangent question, okay? So the tangent of 32 degrees equals the opposite, which is x, over the adjacent, which is 1,000. I'm going to put this over 1. We'll use our cross product property, as x is going to equal 1,000 times the tangent of 32. So we're going to pull up our calculator. I'm going to go to the home screen and just remind you that the first thing we want to do with these questions is we want to check our settings. Notice that mine here already is degree. If it wasn't degree, you would want to set it as degree and you'd want to make it as your default. Okay, again, making it your default, then you don't have to worry about it when you go back resetting. So I got to go back and look at what I'm multiplying. 1,000 times the tangent of 32. So let's get a new document here. No, I don't want to save that. Okay, I'm going to get a graphic. So 1,000 and times the trig button, the tangent, go over one more, of 32. Is 624.869. So 624.869, 624.869, 624.869. All right, and now remember we need to add on to that 6 feet there. And And so x is approximately 630.869 feet high for the climber. So that's an example of an angle of elevation question, and remember to keep in mind the height of the person, height of the spotter. That's one where we could just forget a little bit of a component of that. All right, so now an airplane pilot sights a life raft at a 26-degree angle of depression. So, we're out, the Coast Guard, and they're trying to figure out where this person is and give some information. So we got an airplane. Feel free to draw it better than I do. And, if they were looking straight out, this would be their line of sight, but they're not looking straight out. They're looking down, and that down angle is 26 degrees. And they are a height of 3 kilometers above the ground. Now, height or altitude is always perpendicular. What is the airplane's horizontal distance d from the raft? So there's our d. Okay, when you have these questions, since this line up here is parallel to this line, this angle would be 26 degrees. So we're going to circle that angle. So this would be our hypotenuse. That means d would be the adjacent side, and this would be the opposite side. Okay, this is going to be another tangent question. So the tangent of 26, tangent is the opposite over the adjacent, which is the letter d. Okay, this is a two-step question because the variable is in the denominator. So d times the tangent of 26 equals 3. So we're going to divide by the tangent of 26. And all right, so the distance is going to be 3 divided by the tangent of 3 divided by the tangent of 26, which would be 6.15 kilometers. So the distance would be 6.15 kilometers. All right. So that's an example of how we could use that, and we've got an elevation and an angle of depression. So very similar, again, carryover from what we did in the last lesson, but something that likes to get. We like to, kind of see if you can put that into use in these scenarios there. All right, so a nice quick one here, and we're going to deal next with a little more trig stuff, but that wraps this one up. I'll see you back here soon.